This is your new chapter, chapter 4 from your book, and this chapter is about magnetic effect of current. So, before we start with this chapter, first let me just give you a brief history about how this, magnet and current are, the magnetic field and the electric currents, they are connected to each other. In the year 1820, there was one person whose name is oersted. And one day after his lecture, he went to the laboratory and he performed one experiment. And in his experiment, he take a conductor, a magnetic needle, which consists of North Pole and South Pole, and then he took a cell and a key. And he arranged these components right in this way. He placed this conductor above the magnetic needle and he connect the two ends of the conductor to a cell and then a key in this way. So what happened is when he off the key, he finds that this magnetic needle, it is pointing horizontally in this direction. Okay. As soon as he switched on the key, to his surprise, he found that this magnetic needle is deflected. The North Pole goes there and the South Pole come here. Okay. So this is when you on the key, that means you are allowing a current to pass through the conductor. So to his surprise, what he found is that the needle is deflected when the current it is passing through the conductor. And when he reversed the directions of current, that means by changing the positions of positive and negative terminal of the cell, so the current now it is going in the reverse direction. So again, when he reversed the directions of current, Oersted found that the needle is deflected in the opposite direction. Before it is deflected in this way, this is North Pole, this is South Pole, when the current it is going in from left to right. But when the current it is flowing from right to left, then the needle, right, it goes like this, where the North Pole comes here and the South Pole goes there. Alright? So, after this experiment, Oersted, he thought about, what is the cause that makes the needle deflect in this case. So finally he found that there is a magnetic field which is actually produced by this carrying, produced by this conductor which carries a current. Because a magnetic needle can always be deflected by a magnet only, right? So therefore, but in this case, we are not using any magnet at all. It is just the current which is passing through the conductor that deflects the needle. So hence, Oersted concluded that this deflections of the needle, it is nothing but it is due to the magnetic field which is produced around the conductor. So that magnetic field here, it is able to deflect the magnetic needle. Okay. So this is how Oersted uh, was able, or I can say that because of his experiments nowadays, right, he opens a big era. All right. So that means nowadays we are using like many electric circuit, like we have electric devices at home. So all those electric devices, they are actually based on this principle, that is Oersted experiment, or we can say it is the relationship between the current and magnetic field. Okay. Okay, now, so from this experiment, we conclude that this, a current, when passed through a conductor, that conductor always produces a magnetic field. So that is the first conclusion that Oersted made. The second conclusion is that the larger the magnitude of the electric current passing through the conductor, the stronger is the deflections of the needle. That means, in his experiment, he found that as he increased the current, then this needle, right, it deflect more. It deflect before it goes till here, but now when the current in the wire is increasing, then the deflections of the needle it is more. So when the current it is more, it means the magnetic field around the wire is more. So because of more magnetic field, so more deflections of the magnetic needle will be there. So that is the second conclusion, in which the stronger the magnetic field, the stronger is the deflections of the needle. Okay. And the third conclusion is that this current carrying conductor always produce a magnetic field, you know, which consists of a circular lines of force in the form of a concentric circle. Which means, if this is a conductor carrying a current I, then the magnetic field which are produced, from this conductor, they are like a magnetic lines of force in this form of concentric circle. So for this we shall see better in the next, in the upcoming videos. Okay, so that is the third conclusion. And the fourth conclusion is that a charge, if it is at rest, we have seen that a charge at rest always produce a electric field. But when the current is passing through the conductor, it means charge are moving. So when charge are moving, then we get what? We get a magnetic field. So therefore, a charge at rest produces an electric field, but a charge in motion, it produces not just electric field, but it produces a magnetic field as well. So these are the conclusion that has been concluded by Oersted in his experiment in the year 1820. So in the next video we shall see more about the upcoming topics from this chapter, and for that we will see in the next video.